Welcome back to Carneades.org. Today we are going to be doing a video on the subject of abduction, also known as inference to the best explanation. Now we're going to be trying something a little different in this video. Instead of doing a long drawn-out series where we do a bunch of different videos on one subject, we're going to kind of cram all of those ideas into this one video. The video is going to be a little bit longer, and it's going to deal with a wide range of subjects, but they're all going to relate to abduction one way or another. So, in this video, we're going to look at what is abduction, kind of a basic definition of what it is, a couple varieties of abduction, though surely not an exhaustive list. Then we're going to talk about how abduction plays in with Bayesian epistemology, a subject that we've covered recently. If you don't know much about Bayesian epistemology, you can check out my series on the subject. Then we'll talk about abduction and underdetermination, another series we covered recently. Check out the videos if you're interested. It's called A Theory is Just a Theory. Then we'll talk about abduction, how it plays in with skepticism, something we cover almost constantly here on the channel. And finally, we'll look at some very specific objections to abduction. Once again, this is a little bit different style. Usually I would have broken these up into a bunch of different videos, but we've had some long series going on before, and so I want to give this a try. Please leave your thoughts, ideas in the comments below if you like this style, if you want me to go back to the other one, if you like a little bit of both, speak your mind. So, first off, what is abduction? Perhaps it's a new kind of liposuction. Take your abs from beer gut to six-pack with our new abduction surgery. Probably not. Maybe it's the air vents put into the White House under Lincoln. And if you look up here, you can see the ventilation system put in by the 16th president. We like to refer to it as AB-duct iron. Or maybe it's what happens when a bodybuilder steals your child. Based on the strength needed to open that window, I think your son was abducted. Who are we? Probably not. So, to understand abduction, we need to talk about different types of argument. So, there are three main types of argument: deduction, induction, and abduction that philosophers usually talk about. So, the definition of deduction is really clear. Basically, the premises of the argument claim to guarantee or necessitate the truth of the conclusion. If the premises are true, the conclusion must be true. It's a valid deductive argument. If you want more information on deductive logic, we have 100 days of logic for you to check out on propositional logic, categorical logic, predicate calculus. All of these things are versions of deductive logic. Induction, on the other hand, is a little more fuzzily defined. Usually it's defined as the premises of the argument claim to improve the likelihood of the truth of the conclusion. However, under this definition, abductive arguments actually count as a type of inductive argument. Under other definitions, abductive arguments are the more general category and inductive arguments are a specific type. So it's something that's really difficult to space out, and we're not going to go too much into the discussion right now. I'm going to offer you a definition that's somewhat accepted and will be able to get you through most of the readings you'll look into in this subject. So, to separate these two types of non-deductive arguments, because that's what they definitely are, both are non-deductive, we will call inductive arguments those that are only based on statistical data of some kind and not upon any explanatory criterion. What do I mean by explanatory criterion? I mean some statement that is claiming the conclusion is more likely because it is the best explanation or a better explanation. Claiming that because it explains better, it's more likely to be true. That's what we're talking about when we're talking about an explanatory criterion. So abduction, conversely from induction, is going to be arguments that invoke some explanatory criterion. They claim that the conclusion is more likely because it's the best explanation. Okay? So, while the difference between deductive and non-deductive arguments is well established, as I noted, and relatively agreed upon, the difference amongst inductive and abductive arguments is going to be much more open for debate. For now, anything that invokes best explanation, we're going to consider abductive. But like I said, there's a lot of disagreement on that, just for the sake of this video, though. So, deductive arguments would look something like, all men are mortal, Socrates is a man, therefore Socrates is mortal. If the premises are true, the conclusion must be true, so long as logic's working today. Inductive arguments in this definition would look something like this. Almost all men are mortal. Imagine there's one immortal guy wandering around out there screwing up my universal affirmative. Socrates is a man, therefore Socrates is mortal. Probably. If there's only one guy out there, odds are it isn't Socrates. There's a small chance it is, but it would seem this is pretty likely. Abductive arguments would look like this. All the men I've met today were mortal. The best explanation of this is that all men are in fact mortal. Therefore, all men are mortal. Note, the important piece here is we're taking into consideration best explanation. We have brought in a little bit of statistical data. I surveyed a bunch of people and found out they were mortal. Don't ask me how. But the point is, the key that makes it abductive is that we're playing to best explanation. Okay? So, now we're going to take a look at some different varieties of abduction and kind of a more really concrete, specific definition of that principle that lets us do abduction. So, given some evidence E and a list of explanations H1, H2, all the way up to some Hn of E, if some explanation Hi is the best explanation, then different versions of abduction are going to finish this sentence differently. You might say, we can infer that Hi is true. This is a pretty strong criterion. We say the best explanation, we're allowed to infer its truth. We can infer that Hi is true if it meets our standards of good explanations. We're not going to let a really short list of hypotheses, maybe that only has bad explanations, allow us to infer truth. We have to have a certain standard of good explanation that Hi is going to meet for us to allow the inference for it to be true. And finally, we can infer that Hi is closer to truth than our other explanations. Maybe we don't know all of the hypotheses or possible explanations out there, but of the ones that we're looking at, Hi is probably the closest to the truth because it's the best explanation. Right? Now we're going to look at some reasons maybe that you wouldn't want to accept any one of these to finish the sentence, and start looking at kind of some of the underlying problems that are going to show up again and again when we're talking about abduction. So, we can infer that Hi is true. This seems really strong. This is basically saying this is almost a deductive argument. So, it might be possible that our list of hypotheses is not exhaustive, and in fact, none of them are true. Maybe it is the case that the best explanation is the true one, is the true answer, but we don't have it on our list of hypotheses, and we wouldn't know that. Or that even out of an exhaustive list, the best explanation might not be true. It might be the second best explanation that is in fact true. Truth doesn't necessarily track with explanatory power. So it seems that it's really strong to claim that Hi is going to be true. Maybe then we'll take it back a notch. We'll say, Hi is true if it meets our standards of a good explanation. While some philosophers have put this version forward to vindicate abduction, it lacks a really specific definition of what our standards of a good explanation are. And it seems unlikely that such standards are always going to be shown to track truth. However, if you think you have a good set of standards, offer them in the comments below. I would love some necessary and sufficient conditions for what makes a good enough explanation that we're allowed to infer that it's true. Finally, we can infer that Hi is closer to the truth than our other explanations. This seems, of the ones we offered, probably the most promising, and yet it has its own problems. So while this might address the problems of not assessing all the explanations, it fails to demonstrate the link between truth and explanation. It's easy to imagine a scenario in which the best explanation that's out there in fact doesn't reliably track truth. We might have the best explanation of all the possible hypotheses in our subset, and yet that might in fact be the true statement or be the truth of the world. Therefore, there's no reason to believe that the best explanation of a subset of all possibilities will be the closest to the truth. We're actually going to look at another objection to this in the objections section, so stay tuned. Now, however, we're going to talk about abduction and how it plays with kind of some of the other philosophies that we've been talking about lately. Today we're going to talk about abduction and Bayesian epistemology. So, carry on my wayward son. If you haven't been following our series on Bayesian epistemology, it's provided us with a logically valid way to reassess degrees of belief. We're assigning all of our degrees of belief numbers 0 through 1, 0 being certainty of not P, not the proposition, and 1 being certainty of P, whatever the proposition is. However, in order to use this method, we must have prior probabilities of all of these claims. Bayes' theorem can only generate probabilities from other probabilities. If you're confused by this or you want more information on Bayesian epistemology because it sounds cool, check out my series on it. So, when at last we left the Bayesian, they were trapped in the jaws of something called the problem of the priors. Basically, they had no concrete way to assign prior probabilities to hypotheses, evidence, or the conjunction of hypotheses and pieces of evidence. And they need all three in order to run Bayesian epistemology. You can't just have one or two of those pieces. You need all three pieces in order to correctly conditionalize. So, Lipton thinks that abduction can solve the problem of the priors for the Bayesian. Lipton is going to claim that Bayesians should be what he calls explanationists about prior probabilities. Basically, he says they should assign those hypotheses with better explanatory value higher prior probabilities, and those with less explanatory value lower prior probabilities. Therefore, we've solved the problem of the priors, because we have explanation to do all of that dirty work, and we've kind of explained how abduction can be used in an important way without claiming that it's really going to give us deductive certainty of anything. Seems too good to be true? Well, I think it is. So, one might still worry how exactly such explanatory concerns should be weighted. How do we decide how much we should weight a specific explanation? How much does it have to explain for it to get a higher or higher rating? And more importantly, to my original objection in the problem of the priors, what degree of belief should we assign to the claim that we should assign priors based on explanatory considerations? That very claim, it's not going to be certain because certainty is a problem for the Bayesian, but we have no way to pick something to assign it to because it's the claim that tells us how to assign prior probabilities. It's quite a problem. But even imagining we construct a salient system for assigning prior probabilities to hypotheses, there's no way that we could assign them to pieces of evidence, or the conjunctions of evidence and hypotheses. It makes no sense to say that a particular piece of evidence is more explanatory than another. Well, hypotheses can explain or not explain evidence. Evidence itself doesn't explain something. It's just the evidence we have in the world. So, while at the best, this might help us assign prior probabilities to our hypotheses, it does nothing to help us assign prior probabilities to our evidence, nor to the conjunctions of evidence and hypotheses. And we need those two other things in order to conditionalize. So, at best, abduction can solve a third of the problem of the priors. It cannot rescue Bayesian epistemology. So, next we're going to talk about abduction and underdetermination. Once again, if you don't know what underdetermination is, check out my series on the subject. So, Charles Sanders Peirce is going to talk a little bit about abduction and offer a version that looks like it might be able to help with underdetermination. He says abduction is about creating a new hypothesis when faced with a contradiction, or surprising or strange claims. Well, if you know anything about the problem of holistic underdetermination, you know that that's our very problem. Basically, when we reach a contradiction, we don't know which of our theories to throw out, because it could be the theory we're testing, but it also could be any of our background information or previous scientific or non-scientific theories to throw out that's causing the problem. So, Peirce is going to offer the following explanation of how abduction works and how a theory might be abductively justified. So, some surprising or out-of-place fact is observed. If some hypothesis were the case, this would make that fact not surprising or out of place. Therefore, there's a reason to suspect that that hypothesis is true. Basically, this is more a way for kind of forming new theories than perfectly justifying them. It's a way to pick which theory is going to rise out of the ashes of a contradiction. So how can this help with underdetermination? Well, some philosophers, Dovin and others, claim that in this context, abduction can be used to solve the problems of underdetermination. In the case of holistic underdetermination, abduction, or explanatory criteria, could be used to determine which theory to discard in cases of surprising or contradictory evidence. Well, discard the one that's the least explanatory, and hold on to the one that offers the best explanation. And in contrastive underdetermination, abduction might furnish us with reasons for suspecting that we can choose between empirically equivalent hypotheses because one might have more explanatory power than another. And as long as explanatory power is a valid way for us to pick between hypotheses, we can actually break that deadlock. However, once again, it seems too good to be true. So this objection, just like the one posed by Larry Loudon in our series on underdetermination, continues to underestimate the power of the holistic underdetermination objection. The claim that theories with explanatory power are in some way more likely to be correct is simply another ampliative principle like Occam's razor we talked about in the series on underdetermination that could itself be thrown out to resolve contradictions. Remember, anything in our web of belief is allowed to be thrown out to resolve a contradiction because there's no rational way for us to pick between them. Additionally, there's no clear way in which very simple claims, like the laws of logic, could be more explanatory than some of our complex and intricate theories. It seems like really simple statements aren't very explanatory of the world, and yet complex theories explain a lot more. But it would seem that one would be hard-pressed to say that we should throw out the LEM, the law of the excluded middle, before a more dubious but higher-level scientific theory that explains more about the world. That just seems really strange. And you'd be hard-pressed to put it to someone who's a scientific realist and kind of trying to fight against the problem of underdetermination. Now, in terms of contrastive underdetermination, the abduction's response is going to be equally unconvincing for a couple of reasons. First off, explanatory criteria are going to be much more subjective than empirical predictions. So saying that one particular theory is more explanatory than another is not going to have kind of the same weight that showing that one makes different predictions than the other, and then this one's predictions didn't come true while the other one's predictions did. Also, it does not account for the problem of transient underdetermination, which, as we learned, is a part of the larger umbrella of contrastive underdetermination. Since not being able to account for undiscovered hypotheses is a problem for abduction as well. Basically, transient underdetermination is saying that there are empirically equivalent alternatives that we may discover in the future. Or there are things that we haven't assessed, there are theories that we haven't put to the table. That's a problem for abduction because abduction doesn't assess all the hypotheses. It can't, because it can't look at all those hypotheses that we know not of. Okay, now we're going to move on to talking about abduction versus skepticism. We might think that even if abduction can't help us with the problem of the priors in Bayesian epistemology or our problems of underdetermination, abduction might be able to help us solve the problems of skepticism and show that at least we can know something. Come on. But as I've argued in many videos on this channel, I don't think it's going to work. So, perhaps abduction can provide us with a method for dealing with skeptical scenarios. This claim is important because it was notably put forward by Bertrand Russell, a pretty famous philosopher. If there are two duplication scenarios, but the ordinary world one better explains what we see than the skeptical scenario, then, if abduction is a valid method, we could have reason to assert one over the other. If you don't know what I'm talking about with skeptical scenarios, duplication, and all that, check out my series on skeptical scenarios and the duplication argument from Thought Experiment Month. The problem, of course, is going to lie in the fact that we can't know if abduction is reliable or a valid method in this world or not. We could imagine two different worlds, one in which abduction works and one in which abduction doesn't, or one in which abduction tracks truth and one in which it doesn't. we could imagine a skeptical scenario where all of the best explanations for phenomena were in fact incorrect. They're actually wrong. In such a world, abduction is not going to be a valid method of argument because it's never going to be a reliable one. It's never going to track truth. The problem is, we can never know if we're in that skeptical scenario or not. We don't know if we're in a world where abduction works or not. And the only way to show that abduction works is to show that we're in a world where abduction works. But we can't do that until we've already shown that abduction works. Clearly, it's a circular argument. So, in order to know that we're not in such a world, we already need to know that abduction is reliable. But the only justification for the reliability of abduction is the claim that we're not in such a world. Therefore, any such argument is clearly circular. Now, we're finally coming to the end of the video. We're going to talk about very specific objections to abduction. We've kind of flirted around these objections throughout the whole video. Here we're going to state them clearly and plainly to get them out on the table. So, one of the two objections we're looking at is odds are against informative theories. What do I mean by that? The more information that a theory provides, the less likely it is to be true. Therefore, more explanatory theories are in fact less likely to be true. What do I mean by that? Well, imagine I tell you about a man, Scott, who lives with his parents, sleeps till about noon, has no employment, plays video games all day, and just graduated college. Tell me, which of the following statements is more likely? Scott lives in Missouri, or Scott is under 40 and lives in Missouri. Now, you might think it's really likely that Scott is under 40 based on the information that I gave you. Yet, the first claim that Scott lives in Missouri is always going to be more likely than the second. Why? Because when we're dealing with probabilities of conjunctions of and statements, we're always going to multiply the probabilities. So take the probability that Scott lives in Missouri as 0.01, and the probability that Scott is under 40 is really likely, 0.99. The problem is, the probability that Scott lives in Missouri and is under 40 is going to be the product of those. We have to multiply them together. So we're going to get 0.0099, which is going to be less than 0.01, the probability that just he lives in Missouri. So it's always going to be more likely that he lives in Missouri than that he's under 40 and lives in Missouri. The point here is the more information you provide, the less likely something is. The only way you can even get the same probability is if you have a certainty, a logical certainty, in there as part of your conjunction. Those are few and far between, as we've talked about in Bayesian Epistemology. They're arguably a huge problem and contradictory to have. And even then, it will never improve your probability, it'll just leave it the same. So a more informative theory is actually going to continually be less likely. So the better explanation is actually going to be less likely to happen. If a theory or hypothesis is more explanatory, it must be more informative. That's just what informative and explanatory means. If it's more informative, then it must be less likely. Therefore, more explanatory theories are in fact less likely than less explanatory ones. So there's absolutely no reason for us to think that best explanation is something that's going to track truth. Now, the last problem we're going to look at for abduction is going to be the problem of bad lot. This is a problem we've stated in different ways a lot throughout this video. We're going to look at a really specific version of it and how it applies to the next video we're going to make. So, problem of bad lot is basically there's no way for us to ever have an exhaustive list of hypotheses to choose from. Some people, however, might defend abduction in the face of this. They might say that, well, we could stick a hypothesis at the end of our list, and this hypothesis is just a conjunction of basically not any other hypothesis that we picked. So not everything else, or something we haven't listed. Kind of thing. A kind of catch-all, none of the above answer E on your test. We'll call that HM. None of the previously listed hypotheses are correct. There's no way to know the explanatory value of all the other hypotheses. Basically, this is going to be insufficient to solve kind of the problem of not having an exhaustive list, because there's no way to access the explanatory value of hitherto undiscovered hypotheses. Because none of the previous listed hypotheses are correct isn't a hypothesis. It's just kind of an explanation that it could be nearly anything. And any of those new hypotheses out there that are even just slightly different from our current hypotheses or very different from our current hypotheses may be much more explanatory. It's not going to be sufficient. So, similarly, claiming that a hypothesis is the best explanation in a set is the closest to the truth is simply going to be incorrect. And this is where we're going to give a good argument for this. So, even if we assume that the best explanation overall tracks truth, so assume we're not in one of those duplication worlds, assume we're in a world where the best explanation of a set of explanations for a piece of evidence is always going to track truth. It's always going to be true. Imagine that there's a piece of evidence that can be explained in two general but very different ways. Let's call them Camp A and Camp B. Each of these camps has a list of specific hypotheses that increase in explanatory power as they go down. So A2 has better explanation than A1, A4 better than A3, B5 better than B4, and so on and so forth. Because the two theories are very different, all of the hypotheses in each camp are closer to each other than any other hypothesis in the other camp. So A1 is closer to A4 than A1 is closer to B1, B2, B3, B4, or B5. Currently, of our set, the most explanatory hypothesis of the 9 that are presented is going to be hypothesis B5. But now imagine that there's another hypothesis, A5, which is not only the best explanation of the whole set, but in fact it is true. And because we're in a world where best explanation tracks truth, it's the best explanation out there, period. This would mean that even though B2, B3, B4, and B5 are better explanations than A1, A1 is closer to the truth than any of them. And we're still in a world where best explanation still tracks truth. Why is this a problem? Because a second ago, when we didn't have hypothesis A5, the argument would have shown that B5 is closest to the truth of that set of 9. But in fact, we now are able to say for sure that A4 is the closest to the truth of that set of 9. And A3 and A2 and A1 are all closer to the truth than B5 was. B5 is about halfway down the block of hypotheses as far as closeness to the truth. So there's no way for us to assuredly say that B5 is going to be the closest to the truth. Now, one might claim that this is an impractical example, and it wouldn't actually happen in a modern discussion. Yet, I would argue that it seems that this is in fact one of the most common uses of abduction in modern debates. And we're going to give you a little teaser of the videos to come. So, it's really clear to see in the evolution and creationism debate, which we're about to dig into when we talk about design arguments. Each side is constantly creating better and better explanations of the data, such that their first explanation or their first hypothesis is much worse than their current best explanation. And yet, though the top candidates from each camp are surely the two best explanations for the evidence, because they've accounted for all the new evidence that has been more recently presented, the original, unexplanatory hypotheses of whichever camp is correct is going to be closer to the truth than the best explanation from the other camp. So, the two best explanations for the diversity of life that we see might be a very modernized, clear, explanatory theory of evolution and an intelligent design creationism theory. They're the two best explanations for the data we see. Now, imagine for a second that the evolution theory is slightly better, more explanatory than the creationism one. Does this imply that the evolution one is closer to the truth? Not necessarily. If the creationism camp then were to form a more explanatory hypothesis that happens to be true, every previous creationism theory would be closer to the truth. In fact, that very basic unexplanatory idea of creationism would be closer to the truth than evolution, because it would be the fact in that world that God created life, which is much closer to the truth than the top theory in evolution. Or conversely, you can think about it the other way. If the most explanatory theory we have right now is the intelligent design theory, then even if we later discover that evolution is in fact true, the problem is that the least explanatory of the evolution theories is still going to be closer to the truth, even though on our original assessment, the best explanation, the most recent intelligent design theory, should have been the closest to the truth. This is a problem for abduction, and it's a problem for the arguments coming from either the evolution or creationism camp that say the reason that their claim is correct is because it's the best explanation of the data. We're going to talk a little bit more about this in our next videos on the teleological argument. So, stay tuned for the specific applications of abduction to the teleological argument. That was just a little bit of a teaser. Coming up next, please offer your comments on kind of this longer video format down below. Watch this video and more here at Carneades.org, and stay skeptical, everybody.